Okay, what we have here is an optimization problem where you're trying to pick an ideal value for something. They're selling season tickets here. They say right now they're selling 7,200 season tickets and they're making 1,400 on each of them. And now they're finding that if they raise the price of the tickets, yes, they'll make more money, but they'll also lose some customers. Any kind of curve like that, any price curve, tends to follow some kind of quadratic pattern, like so, where this is the price of the thing that you're selling. If you give it away for free, you make no money. If you raise the price, you make more money for a while, but eventually you start charging too much and losing customers until up here you've chosen a price so high that no one buys from you anymore and you make no money. Somewhere in between, right here, is the sweet spot where you're making maximum money, and that's what we need to find. So let's see how we can do this. Write expressions for the cost of a package of tickets and the potential number of tickets holders. Well, what we have right now, the status quo before we change anything, is we're selling 7,200 season tickets. We'll leave some space there, there's more coming. And we're making $1,400 off each one. So that's our revenue now. And the change we're considering making is this. We can increase the price by $25 and lose 100 customers. So this 1,400, we could add 25 to it, but the bad news is we lose 100 over here. Now, the way I wrote this, it looks like we've just done this once, but we could do this any number of times. We could make 2 $25 increases or 10 $25 increases, and if we do that, we lose 100 people 2 or 10 or however many times. So we're saying if you make X number of $25 increases, you'll have X number of 100 customer losses over on this side. And the product of those two things tells you how much money you're going to take in. You can see if we FOIL this, the numbers will be a little crazy, but we will get a quadratic out of it. We'll get 7,200 times 1,400, which is, what is that? 1,080,000? 10,080,000. And then we'll get 7,200 times 25x, which is 1,800, 180,000. X. Then we have minus 100 times 1,400, which will be minus 140,000x. And then we have minus 100 times 25x, which makes minus 2,500x squared. I'll move down to here because I need the space. That means overall our revenue is, putting it in descending order now, minus 2,500x squared. 180,000 minus 140,000 is plus 40,000x plus 10,080,000. So that's our expression for the revenue. You can see this is a parabola opening down. So yes, it should have some kind of inverted U shape like this, where it has a maximum to it, and that's what we're trying to find. So let's see. They put a couple of different parts in this question to help guide us through it. We'll just follow along. Determine the price of a package of season tickets that would generate maximum revenue. Okay, well, that means we need the vertex. We can find the vertex for this if we write it in a form like standard form, where we have x minus h squared plus k, or x minus p squared plus q, whatever you like. So we get to complete the square. Completing the square means factoring minus 2,500 out of those first two terms, By the way, if you want to do this on the calculator and find the maximum that way, I don't blame you, but if you're gung-ho and want to complete the square, I'll do this so that you can see how it'll work. Okay, we get 40,000 divided by 2,500, 16 I believe. So we get minus 16x, leave some space, plus 10,080,000, sorry. Now, completing the square, we take negative 16, cut it in half, that's negative 8, square it, that's 64, so we put a plus 64 here. And then to make up for that, we have to do a minus 2,500 times minus 64. Okay? Minus 2,500 times plus 64 here, and then minus 2,500 times minus 64 to cancel it out, so there's no net change. So this is minus 2,500. This factors, like it always will if you've completed the square correctly. X minus 8 all squared. And then we get plus 10,080,000. And then we get minus 2,500 times 64, which is 160,000. So, finished form, this is minus 2,500, x minus 8 all squared, plus 10,240,000. That means the location of our vertex here is 8, 10,240,000. What does this mean? This is our x, and this is our revenue. So the vertex is telling you the best money you can possibly make is $10,240,000. How do you get it? Make x 8, which means, come back up here. When we wrote this, we said the price would be $1,400 plus 25x. That means 1,400 plus 25 times, the math is telling us use 8 here. That would be 1,400 plus 200 would be 1,600. So that's your optimal price. Now, their next question, how many ticket holders will there be if you implement this plan? That's up here too. 1,400 plus 25x is the price for your tickets. This is your ideal number of customers, 7,200 minus 100x. So 7,200 minus 100 times our optimal number here is 8. That's 7,200 minus 800 equals 6,400. So we'll be down to only 6,400 ticket holders, but we'll make better money anyway because our ticket price will be higher. And how much more revenue would be generated if the plan was implemented? The amount we're going to make, we will make 10,240,000. That's the vertex, meaning it's the highest amount we could possibly hope for. We never did quite find, well, we kind of did. The amount that we were making before, you can find a couple of ways. The quick way is multiply these out. 7,200 times 1,400 is our current amount. But we did that already, didn't we? We multiplied it out, and the result we got was this, 10,080,000. This is what happens if x is 0, meaning this is what happens if we don't change anything. We'll make 10,080,000. So before the status quo amount, the amount if we don't do anything differently, is 10,080,000. Subtract those, and you find $160,000 is the difference you can make by tweaking your prices.